Let us look at this question, which is taken from set theory, statistics. We want to know how we can answer it. So when we look at this question, the question is, which of the following represents the shaded region? So we are given options A, B, C, D, and E. We want to know which one represents the shaded region. So I'm going to have two approaches to this question. The first approach is going to be intuitive. We are going to try to reason out the answer to this question. Then the second approach, we are going to eliminate options which do not lead us to the answer. In other words, we are going to try out every option of those 6 options so that we can see which one is an answer. Actually, there are 5 options from A to E. So let us try this. We want to know what represents the shaded region. But when we look at it, we can see that we have 3 sets inside this sample space or a universal set. We have set A, set B, and set C. Now, to start with, let us say A, right, referring to this set, union B, referring also to this set, but we want to take the complement. So we are taking the complement of the union of A and B. This should represent the outer part which is shaded. But we also have this C. So to accommodate this C, it's just going to be a union of C. Something like this. So this is the answer we are getting from intuition. You should remember, maybe let us put it down. You should remember that union actually means to add. That's why it is connected with the addition rule when we look at the different theorems of probability, which we are going to do when we answer questions which have something to do with probability. Then an intersection then usually refers to multiplication. That is in the sense of probability, but when we talk about sets, of course we are referring to commonality. What is common between 2 sets? So this is going to be our first option, A union B complement, then also union C. This union is adding this small shaded set of C, which also happens to be a subset of the set A. Now let us do this. Let me remove this. What do we want to do? If we are going to apply the De Morgan's law, we are going to find out that there is a different way of expressing what we have written here. So this is going to be my answer option 1. I want to write down answer option 2. So how am I going to do that? We can re-express the complement of A union B in this way. Instead of saying A union B complement, we can rather say A complement intersecting B complement. That's another way of expressing A union B complement. So if you look in the first case, the complement is over the whole union of A and B, or A or B to be more precise. But in the second part, because we no longer want the complement to be over A or B, we want it to be over A and B separately. This is how it's done. So A union B complement is the same as the complement of A intersecting the complement of B, but this part of C comes as it is. So these are the 2 options we are having. And when we look here, we are going to see that they actually opted for our second option. This is where we have the complement of A intersecting the complement of B union C. So this is going to be our answer. But before we go there, as a student of mathematics, we should always strive to understand things beyond just cramming them or rote memorization. So let us just take a few minutes to prove that A union B complement is going to be the same as saying the complement of A intersecting the complement of B. To do this, let us just have a Venn diagram representation of this. So we have the set S, which represents sample space. Then we have A and B. Let us draw them as joint sets like this. So when we say A union B, we are referring to this part. So this is A union B inside the sets of A and B. But here is the complement, meaning what is outside A union B. For that reason, it means we have to shed outside A union B. So it's going to be more like this. That's what it's going to be. Now, if we apply the same to this, we also have a Venn diagram which has our sample space like that. Let us have A and B. So when we say A complement, what do we mean? So this is going to be A, by the way. So A is this set, including even this part where we have A being intersecting B. But we want the complement of it. So we have to shed outside A, which will be this. But when we are shading outside A, remember, we have to shade even through B, but avoiding this part because it also belongs to A. We just want to shade everything outside A, like that. Okay, now let us look at it intersecting the complement of B. So we know that when we talk about an intersection, we have to shade differently so that we can see the crisscross of lines which tell us the intersection. So to shade for the complement of B, I'm going to use horizontal lines. So the complement of B, we are shading everything, but we don't have to shade B. So it's actually going to be more like this. We don't get into B. It's like this, as you can see. This is what it is like. Now when you look at the intersection or the crisscrossing of lines, you can see that even though inside A we have these reddish lines, they are not crossing anything. Inside B we have these slanting lines, they are not crossing anything, to imply that the crisscross is only found outside. So because of that, if we want to sum up things, this is actually going to be like this. A, then B. We are actually just shading outside the union. So by so doing, we have proved that the complement of A union B is the same as the complement of A intersecting the complement of B. But I would also want you to know that we can actually have A intersecting B complement, which is also going to be taken if we want to re-express it as the complement of A union the complement of B. So the secret here is when we want to re-express from having a whole sum complement to just having complements affecting individual sets, it's going to change here. This is the change. You should actually be careful of this change. You should be careful of it. Okay, so we have proven this. but we also have a long way to go. Of course, we know our answer, but we just don't want to leave it there. So what I'm going to do is, on this space here, I'm going to be drawing up these other options to disprove them. So when we look at A, for example, it's saying A union B intersecting C. So it's going to be like this. Let us see if it is correct or not. So we have A. So we are going to, in our representation, right, we should just copy the structure and see if A union B intersecting C is going to produce something like this. So A is going to be drawn as it is. Inside A, that's where we have C. Then B drawn as it is. A union B, what does it mean? So A union B, it means we are shading inside A and also shading inside B. But this A union B is actually intersecting C. You understand? So because it is intersecting C, it's going to be more like this. When we look at this, it's so much different from what we are having here. So the first one is disqualified on that grounds. Now let us go to option B to see what it's going to be like. So in order for us to go to option B, we have to remove this part. We have removed it. Our option B, what is it saying? It's saying the complement of A union the complement of B, like that. And I just have to remind you that this can be written as what? A intersecting B complement, just to remind you. But we want to represent this on a Venn diagram. So we still have A, inside A the subset C, and here we have B. When we say the complement of A, we are referring to shading everything outside A. So we just don't shade in A, we are shading everything outside A, including inside B, like this. Then when we say union the complement of B, what then is the complement of B? So because it's a union, I'm going to shade with the same type of lines, that is vertical, for both cases, but they're just different colors to show you what's happening. So when we shade the complement of B, we are shading everything, but we just don't want to get to shade inside B, like this. So we are shading even inside A. So if we want to need to represent this so that it is more neater, allow me to remove this part. What we are going to do is, this then is going to be, so it's S, right? Then A, C, B. What it is going to be is more like this. We are going to shade here, but we also get inside A because it was a union, like this. Then we also shade here, we also get inside B. So as you can see, this is not how this is represented. So this makes B a wrong answer. It disqualifies B. Let us quickly go to C. Maybe we might represent C here. So what is C saying? A union B union not C. So it's like this. We still have A with C inside, then B. Let us show what A union B is. So we are looking at the union of A and B. So we have to shade inside A like this. This is A. Union B, we shade inside B. Then we also have to shade outside C. So when we are shading outside C, let me use a different color so that you see what's happening, because this is union C complement. So shading outside C includes shading inside A but not passing through C. It's more like this, even inside B. So if we want to show this more clearly, it's more like this. So A, C, B. So since it's a union throughout, it means everything shaded should be kept like that. So it's like this. As you can see, it's actually shading everything. What this is implying is there's a similarity here, and you might actually try to prove it. But since it's similar with something which is wrong, we can say that it is itself wrong. Now let us just do D, because we've already proven that E is our answer. So let me remove this part. Let us see what D is going to be like. So D, it's A intersecting, not B intersecting C. That's what it is like. So let us first represent A intersecting, not B. Of course, you know that we are always going to respect things which are inside the brackets, I mean. So we start with that which is inside the brackets. So this is the Venn diagram. A, C, B. Now, when we say A intersecting, not B, let us shade A using these lines, vertical lines. But it is intersecting, not B. So let us shade not B. When we shade not B, let us use flat lines. We just have to make sure we don't pass through B. So it's like this. But this is now also intersecting C. So let us use a different shade to show the intersecting of C. So this is C. So when we represent this to show what's really happening, it's going to be like this. This is S. So since it's an intersection throughout, we want to find a region where all lines are intersecting. Like you can see this region of C, we have these slanted lines intersecting with this crisscross of vertical and flat lines. So that is actually the region we are looking at or looking for. C, then B. So what it means, if we simplify this, it's actually just this part of C which is going to be shaded, because that's where we have all the lines intersecting. That being so, that makes this wrong also. So I've just shown you two methods. Method number one, you can reason it out using your knowledge of set theory to find which answer it is. But if you are not sure, you can try out quickly all the options to see which option gives you what is represented in the picture. But make sure that when you draw your Venn diagrams, you just have to copy this and see if your shading inside your own Venn diagram is going to be the same as this. Thank you. If you have any questions, please don't hesitate to ask in the comments. If you have any contributions, you can do the same. If this video and any of our videos are helping you, it will be an honor if you consider subscribing. Thank you.